When people begin working seriously with large language models, one of the most important realizations they eventually reach is that the model is not trying to understand what the user means. Instead, the model is trying to predict what text should come next based on the statistical patterns present in the prompt and in the vast dataset it was trained on. This may sound like a small distinction, but it has enormous practical consequences for how prompts should be written. A prompt that seems clear to a human reader can still be interpreted in several different ways by the model, because the model is responding to patterns rather than intent. The discipline of writing prompts that the model cannot misinterpret begins with understanding this difference. Humans communicate with each other using an enormous amount of shared context. We assume that the listener understands our intentions, our background knowledge, and the conventions of the conversation. Because of this, human instructions are often compressed. We leave out steps, omit definitions, and rely on implicit assumptions. Language models do not share that implicit understanding. They only see the text that appears in the prompt, and they interpret that text by activating patterns learned during training. If the prompt leaves important details unspecified, the model will fill those gaps with the most statistically probable interpretation. Sometimes that interpretation will match the user's intention. Often it will not. Instruction clarity begins with the recognition that ambiguity is the enemy of reliable outputs. Ambiguity arises whenever a prompt can reasonably be interpreted in more than one way. This may occur because of vague wording, missing context, conflicting requirements, or undefined output expectations. The more ambiguity a prompt contains, the wider the distribution of possible outputs becomes. When the distribution is wide, the probability that the model produces the exact result the user wants becomes smaller. Consider how humans normally give instructions in technical environments. In software engineering, precise specifications are essential because computers cannot infer intention. Prompt engineering requires a similar mindset. The prompt must act as a specification that clearly defines the task, the scope, the constraints, and the expected output. One of the most common sources of ambiguity in prompts is vague task definition. For example, a prompt might ask the model to analyze this text. Analysis can mean many different things. It might mean summarizing the content, identifying themes, evaluating arguments, extracting entities, or critiquing the logic. A human reader might infer the intended meaning from context, but a language model must rely entirely on the prompt. A clearer instruction would specify exactly what type of analysis is required. Another frequent problem occurs when prompts rely on words that appear precise but are actually subjective. Words such as brief, detailed, high quality, or professional do not have fixed meanings. Different authors use these words in different ways. The training data contains many interpretations of these terms, so the model cannot reliably infer the exact expectation. A prompt that says write a brief explanation might produce 2 sentences in one case and 2 paragraphs in another. Instruction clarity improves when subjective words are replaced with measurable constraints. Instead of asking for a brief explanation, the prompt might request an explanation of 3 sentences or fewer. Ambiguity also arises from implicit audience assumptions. In human communication, speakers automatically adjust their explanations based on the perceived knowledge level of the listener. Language models can do the same, but only if the prompt specifies the intended audience. Without this information, the model must guess the appropriate level of complexity. For technical subjects, this can lead to responses that are either overly simplified or unnecessarily complicated. Another subtle source of misinterpretation is the presence of multiple tasks within a single prompt. A prompt might ask the model to summarize a document, evaluate its arguments, and propose improvements. Each of these tasks requires different reasoning patterns and output structures. If they are not clearly separated, the model may blend them together or emphasize one task more than the others. Instruction clarity improves when complex requests are broken into explicitly defined steps. The structure of the prompt itself also influences clarity. Long paragraphs containing several instructions can be difficult for the model to parse because the boundaries between tasks become blurred. Clear separation between instructions helps the model identify which parts of the prompt define the task and which parts provide context. Context itself is another area where clarity matters greatly. Background information can help the model produce better answers, but only when the context is relevant and clearly connected to the task. If the prompt contains large amounts of unrelated information, the model may struggle to determine which details are important. This phenomenon is sometimes described as signal dilution. The more irrelevant text appears in the prompt, the weaker the influence of the critical instructions becomes. Instruction clarity also benefits from explicit constraints. Constraints define the boundaries within which the model should operate. They can specify the length of the response, the format of the output, the tone of the explanation, or the type of reasoning to apply. Constraints reduce the size of the solution space, making it easier for the model to generate outputs that match the user's expectations. Another powerful technique for improving clarity is the use of step-by-step instructions. When tasks require reasoning or analysis, the prompt can guide the model through the process by specifying intermediate steps. This encourages the model to generate a structured reasoning path rather than jumping directly to a conclusion. Step-by-step prompting is particularly useful for complex analytical tasks, mathematical reasoning, and multi-stage problem solving. Clarity also depends on consistency within the prompt. If different parts of the prompt use conflicting language or incompatible instructions, the model must reconcile those signals statistically. For example, a prompt that asks for a highly technical explanation but also instructs the model to avoid technical terminology creates a contradiction. The model will attempt to satisfy both conditions, often producing a response that satisfies neither. Another important aspect of instruction clarity involves distinguishing between instructions and examples. Examples are extremely powerful signals because they demonstrate the exact pattern the model should follow. However, if examples are mixed with instructions in an unstructured way, the model may treat parts of the examples as instructions or vice versa. Clearly separating examples from instructions helps the model understand their roles. Clarity also benefits from careful word choice. Natural language contains many expressions that humans understand intuitively but that introduce ambiguity in statistical interpretation. For instance, phrases like improve this text or make it better provide almost no concrete guidance. Improve it in what way? More concise, more formal, more persuasive, more technical, or more readable? A clearer prompt would define the dimension of improvement explicitly. Once instructions are clear, the next major challenge in prompt engineering involves controlling the structure of the model's output. Even when the model understands the task perfectly, the format of the response may vary widely unless the prompt explicitly specifies the desired structure. This leads to the second major concept we will examine: output formatting. Output formatting refers to the practice of designing prompts that force the model to produce responses in a predictable and structured form. This is particularly important when the output will be consumed by software systems, integrated into reports, or used for automated processing. Language models naturally produce free-form text because most of the training data consists of natural language documents. Without guidance, the model will often respond in paragraphs of explanation. While this may be acceptable in casual conversations, it becomes problematic in technical workflows where structured information is required. Forcing structured responses begins with explicitly defining the format in the prompt. If the user wants a list, a table, a set of labeled sections, or a specific data structure, the prompt must state that requirement clearly. The model can then align its output with the requested structure. Structured formatting works because the model has seen many examples of formatted text during training. Tables, lists, structured documentation, and labeled data appear frequently in technical materials. When the prompt specifies a particular structure, it activates those patterns within the model's internal representations. One of the most common structured formats used in prompt engineering is the list. Lists provide a simple and predictable way to organize information. By asking the model to produce a numbered list or a fixed number of items, the prompt creates clear boundaries for the output. Another widely used format is tabular output. Tables allow the model to present multiple attributes of information in a consistent structure. For example, a prompt might ask the model to compare technologies by listing their advantages, disadvantages, and use cases in a table. This format not only improves readability but also ensures that each item is described using the same categories. Structured outputs become even more powerful when they are designed to be machine readable. Formats such as JSON or structured key-value pairs can allow downstream software to parse the model's response automatically. When prompts specify these formats clearly, language models can produce outputs that integrate directly into automated workflows. However, achieving reliable structured outputs requires careful prompt design. The prompt must define the structure unambiguously. If the format description is vague, the model may produce a structure that resembles the requested format but does not conform exactly to the expected pattern. Another important principle in output formatting is consistency. If the prompt requests multiple items with identical fields, the model should produce the same structure for each item. Inconsistent formatting can make automated processing difficult. Explicit instructions that define each field help maintain uniformity. Output formatting can also be combined with validation instructions. The prompt can ask the model to ensure that its output conforms to the specified structure. Although the model cannot truly verify correctness in a deterministic sense, this instruction encourages it to re-evaluate the structure before completing the response. A further refinement involves separating content generation from formatting instructions. Some prompts first ask the model to perform an analysis, and then instruct it to present the results in a specific format. This separation helps the model focus on reasoning before structuring the output. It is also important to consider the limitations of formatting constraints. Extremely complex output schemas may be difficult for the model to follow consistently, especially when the prompt contains many nested fields or strict syntactic rules. Simpler structures tend to produce more reliable results. Another subtle factor is the interaction between formatting instructions and token prediction dynamics. Because the model generates text sequentially, early tokens influence the probability distribution of later tokens. When the prompt clearly establishes the output format at the beginning, the model can maintain that structure throughout the generation process. Output formatting is especially important in professional environments where language models are integrated into pipelines. Structured outputs enable automatic evaluation, filtering, and downstream processing. Without consistent formatting, the usefulness of the model's responses may be limited. Instruction clarity and output formatting together form the backbone of disciplined prompt engineering. Clear instructions ensure that the model understands what task it should perform. Structured formatting ensures that the result appears in a predictable and usable form. When these two principles are applied together, the behavior of language models becomes far more reliable. Instead of generating unpredictable free-form responses, the model operates within a well-defined environment created by the prompt. The prompt becomes a specification that defines both the reasoning process and the final representation of the output. As practitioners gain experience with prompt design, they begin to see prompts less as casual questions and more as carefully engineered interfaces between humans and machine intelligence. The goal is not simply to ask the model for information but to design prompts that align the model's probabilistic generation process with the precise requirements of the task. Once this perspective becomes internalized, many of the frustrations associated with language model outputs begin to disappear. Misinterpretations become easier to diagnose, inconsistent formatting becomes easier to correct, and the overall interaction with the model becomes far more predictable. Prompt engineering, in this sense, is not a mysterious art but a practical discipline grounded in clear communication, structured design, and an understanding of how language models interpret textual context. By mastering instruction clarity and output formatting, engineers gain the ability to transform large language models from conversational tools into reliable components of technical systems.
If you find this video exciting, please like, subscribe, and turn on notifications. See you in the next AI for Beginners educational video.